Welcome back to Mr. Hassan's Maths channel. I'm now answering question number 5 from the Solomon E. Mechanics M1 paper from Edexcel. This is also question number 4 from my M1 end of topic worksheet number 6, which is about momentum and impulse. Here we're told about a cricket ball of mass 0.3 kilograms, which is approaching a batsman at negative 30 I meters per second. Okay, so here we got in terms of vectors, and of course we assume I is like a horizontal vector, going due east. The batsman hits the ball with a 1.5 kilogram bat, moving with velocity 15 I meters per second, so it's going in the opposite direction to that. Contact between bat and ball lasts for 0.2 seconds. Immediately after this, the bat and ball move with velocities 5 I meters per second and V I meters per second, respectively. Suggest a suitable model for the cricket ball. So we'll say, a suitable model, we'll just say a particle. Just one word is enough, one mark. We consider a particle that, it's we consider it so small that the weight acts through one point, and there's no effect of air resistance on it. We don't have to mention that. Just suggest a suitable model. Particle is fine. Okay, then it says calculate the value of V. So let's look at this situation. We have the ball traveling in this direction, minus 30. We'll call this direction positive. Of course, we will take I as due east and, positive due east. So the ball is traveling in this direction. So this is the ball. So before, and we'll think about after. Okay, and this is the bat. Okay, so before, the ball's traveling in this direction at 30 meters per second. And the bat is traveling with a velocity of 15 meters per second in this direction. So in the opposite directions. Okay. Immediately after this, the bat and ball move with velocities 5 meters per second. So, of course, the bat, we assume, is going to be moving in this direction. In fact, it tells you it's in this direction. It's the same direction, positive as well. And the ball, obviously, is going to move in that direction. Okay, it's going to be hit and move in that direction. So that's going to be V meters per second. But that should show up in our answer anyway. Okay, so it says here, calculate the value of V. So what we can do here, we can use impulse. We could use, conservation of momentum. So the conservation of linear momentum states that the momentum before, the total momentum before is the same as the total momentum after. Okay, so what we can say here is the total momentum before. Now we know that the mass of the cricket bat is 1.5 kilograms. So this is 1.5 kilograms, and this is 0.3 kilograms, the mass of the cricket ball. So the total momentum before the collision is going to be 1.5 times 15. And you're going to have plus 1.5 times, plus before this as well, there's going to be 0.3 times, that's going to be negative 30. That's 0.3 times negative 30. And after the collision, the total momentum is going to be 1.5 times 5 plus 0.3 times V. Okay, so this will give us our answer. So we're going to do 1.5 times 15, times 15, plus 0.3 times minus 30. Now that gives us 27 over 2, which is 13.5. So that's 13.5 equals, that's going to be 1.5 times 5. 1.5 times 5, which gives us 7.5. So that's 7.5 plus 0.3 times V. So 13.5 minus 7.5, that's going to be 6, equals 0.3 V. So therefore, we can say V is equal to 6 divided by 0.3. So we have 6 divided by 0.3, which gives us 20. So we can say V is equal to 20 meters per second. That's V. Okay. So it's already mentioned meters per second. We can say V equals 20. V equals 20. The unit's already given. So V is equal to 20. That's the value of V. So this will be then 20 I meters per second. All right. So there we have the answer to part B. As I said, we could have also done it by working out the momentum, okay, the impulse, sorry, acting on the ball, okay, and we could have done that this way. But part C, in fact, involves momentum anyway, and we'll see how. It says, find the magnitude of the force with which the batsman hits the ball. Okay, so what we know is that the impulse is equal to mass times the change in velocity. And the impulse is also equal to the force times the time. So the force times the time that the objects were in contact with each other. And we know that that time was, as I mentioned, 0.2 seconds. The contact between the ball and bat lasts for 0.2 seconds. So what we can do is we can use this formula here. We can say Ft equals mass times V minus U. So we can use the ball or the bat. Okay, now because we have already for the bat both the the information before and after for this the velocities before and after the collision. Okay, it's most sensible for us to use the bat's data rather than the ball, because in case we made a mistake with this V, well, that mistake will carry on to the next question, and because we are able to calculate it without that mistake, we won't have carry on error. So it's best to use what we're given. So I'm going to consider the bat. So I'm going to consider the bat because we have the information already given. That will help us. Although if we consider the ball and we had everything correct, it will still be fine. So we have, we want to find the force. The time is 0.2. The mass of the bat was 1.5 kilograms. And the velocity of the bat at the end, V, its final velocity is 5. Okay, and the initial velocity is 15. So it's going to be V minus U. So it's going to be like this. So you have 0.2 times F is equal to 1.5 times minus 10. So 0.2 times F is equal to minus 15. So F is equal to minus 15 divided by 0.2. 15 divided by 0.2. That's minus 15 times 5, which is minus 75 newtons. So it's, of course, this force is acting. This is the impulse, which we're considering the bat on the ball. So it's going to act in this direction. So that's why it's minus 75. But they want the magnitude. So therefore, we can say the magnitude of the force is going to be equal to 75 newtons. So there's the answer that we want. Now, if we consider the ball, we should get the same answer. We consider the bat because we have both the velocities given in the beginning of the question anyway. But if we consider the ball, we'll still have the same situation where the force we have to find, the time is still 0.2 seconds, but the mass of the ball is 0.3 kilograms. The initial velocity and the final velocity will also be different. The initial velocity of the ball is negative 30 because it was going in this direction, what we call negative. So it's negative 30. And the final velocity of the ball was positive 20. So it should give us the same answer exactly. So we need to find the force. We got the time is 0.2. We know the mass is 0.3. The final velocity is 20. So you have minus the initial velocity, which is minus 30. So it's minus 30. Be careful of the signs here. So 0.2 times F equals 0.3 times 50. Okay, so we have F equals 0.3 times 50 divided by 0.2. So F is equal to 0.3. 0.3 times 50 divided by 0.2, which gives you 75, of course, 75 newtons. So we can see that it's the same answer. It doesn't matter whether you consider the ball or the bat to find that force, because the impulse on the bat and the ball is the same magnitude but in opposite directions. Okay, so there's the answer to this question. Okay, from this paper, from the Solomon E paper, question number 5 and 4 from my end of topic worksheet, momentum and impulse. Okay, as I mentioned before, we could have in fact used the impulse to find this final velocity. So I could have worked out the impulse that is given to the bat, okay, which is going to be basically 1.5 times its final velocity minus its initial velocity. So 5 minus 15, which is going to be basically negative 15 Newton seconds, okay? And we could then find the impulse acting in that direction, which would be the opposite, okay, which would be positive, okay? So we could say that the impulse here is 0.3 times the final velocity, which is what we have to find, minus the initial velocity, which is minus 30, and that's equal to minus 15. And that will give us the velocity of this after the collision. So you have 0.3 times v plus 30 equals, and that will be positive 15 actually. In this direction, it will be positive 15. Okay, because it's the opposite direction. It's a positive direction. That would be the negative direction. So you're going to have v plus 30 equals 15 divided by 0.3. So v equals 15 divided by 0.3 plus 30. So if you do 15 divided by 0.3, that gives you 50. And you're going to have minus 30, sorry. When you subtract 30 from both sides, what am I doing? Minus 30, okay, because you're going to subtract 30. So, of course, that's subtract 30. So, minus 30, and that gives you the answer 20, which was what we found. So, we can use impulse, or we can use conservation of linear momentum to find V. So, I could work out what the impulse is acting on the ball by finding the impulse given to the bat, which is in this direction, minus 15 Newton seconds. Therefore, that in this direction is going to be positive 15 Newton seconds. And so we can say that the change in momentum times the mass is equal to positive 15. And that gives us, that helps us to find what V is. So we could have done this in an alternative way using the impulse as well. Both of those are perfectly fine ways of doing this. Sometimes you're forced to use this method, so you should understand how to use this method also. Okay, that's why I'm explaining it to you. So that's question number 4, as I said, from the end of topic worksheet. Question number 5 from the Solomon e-paper. Other solutions from that paper can be found in the link that will appear over here at the end of the video. Over here will appear a link for this worksheet for questions I've answered from that. You can subscribe to my channel by clicking on this link, and you can find other questions about momentum and impulse that I've answered from the book and from other past papers in the link that will appear over here. Thank you for watching, and see you soon.